Lesson 32, I will interpret quotients and remainders to solve one-step division word problems with larger divisors of 6, 7, 8, and 9. So basically what this learning target means is that we're going to be solving some one-step division problems, but this time we're going to be dividing by numbers that are a little bit bigger, like 6, 7, 8, and 9. So be prepared because we're going to be using the RDWW process in all of these problems. So go ahead and write your name on your problem set, and then let's take a look at the directions. The directions say solve the following problems. Draw tape diagrams to help you solve. If there is a remainder, shade in a small portion of the tape diagram to represent that portion of the whole. So remember, we're going to be using the RDWW process. Even though it doesn't tell us to, that's what we're going to be doing. So the first thing we need to do is we need to read this problem. All right, a concert hall contains 8 sections of seats with the same number of seats in each section. If there are 248 seats, how many seats are in each section? So the first thing we have to do is we have to really think about what's the question asking us. So we're talking about a concert hall, and we're talking about sections. Like if you go to the River Park Center and you buy tickets, there are certain sections that you buy your tickets in. If there are 248 seats, how many seats are in each section? So first of all, we know what our whole is. Our whole is 248 seats. So I'm going to go ahead and label that. That's not exactly the most neat tape diagram. I hope that you forgive me. And then I have to figure out, when it says 8 sections of seats, does that mean that there are 8 in each group and we're trying to figure out the number of groups? Or does that mean that there are 8 groups and we're trying to figure out the number in each group? Well, hopefully you said this means there's 8 groups. So we're going to divide this tape diagram into 8 sections. Now I like to go ahead and divide it into 4 parts like this, and then divide each fourth in half like this, so that I end up with 8 parts. Now I'm trying to figure out how much is in each group, but I know there's 8 groups. So I'm going to put my unknown. I could put a question mark here, or I could put a variable like the letter S, since I'm talking about seats. So if I have 248, and it's in 8 equal groups, I want you to think about how would you solve this problem. I want you to go ahead and work by yourself to figure out how many seats are in each section. Do as much as you can, and when you get stuck, or if you get stuck, you can always press play and I'll talk you through it. Okay, so I thought to myself that this is clearly a division problem. So I took 248 and I divided it by 8. And I ended up with 31 and no remainder. So when I went to go, I already read this problem. I drew a tape diagram. I wrote a number sentence, and then I went to write my answer as a statement. How many seats are in each section? There are 31 seats in each section. All right, so let's take a look at question number 2. In one day, the bakery made 719 bagels. The bagels were divided into 9 equal shipments. A few bagels were left over and are given to the baker. How many bagels did the baker get? All right, so we just read the problem. Now we're going to draw a tape diagram. I want you to think about, again, do we know what our total is? Well, our total is 719 bagels, right? And then we've got this number 9. And we've got to think to ourselves, it says that they were divided into 9 equal shipments. Does that mean that we're going to take 719 and put it into 9 equal groups? Or does that mean that there's going to be 9 in each group? Well, it says that there were 9 equal shipments, so that means we have 9 equal groups. So let's go ahead and divide our tape diagram into 9 parts. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm trying to figure out how much is in each group. So I'm going to use the unknown B for bagels. You could also use a question mark, but I like to use letters. All right, so I'm trying to figure out how much is in each group. So I've got 719, and I know that I'm going to put that into 9 equal groups. I want you to go ahead and finish this problem just like we did problem 1, and then let's come back and check together. Okay, so I knew that if I was going to put this into 9 equal groups, that meant that we were dividing. So I took 719 and I divided it by 9, and that left me with 79, remainder 8. So when I got ready to write my word sentence, I already wrote my number sentence. When I got ready to answer the question, I went back and looked, and I noticed that it's not asking how many bagels are in each shipment. It says how many bagels did the baker get? So if you go back and look, it says a few bagels were left over and given to the baker. So the leftover would be my remainder. So the answer in this case is the baker will get 8 bagels. That is called interpreting the remainder. You had to think about what the question was asking. It's not always asking you the same question. All right, so let's take a look at question number 3. If you're feeling pretty confident and you'd like to try this one all by yourself, go ahead and use the RDWW process, and then you can come back and check at the end. But if you'd like to stay with me, I can help you get started. The sweet shop has 614 pieces of candy. They packed the candy into bags with 7 pieces in each bag. How many bags of candy did they fill, and how many pieces of candy were left? All right, so I just read it. I'm going to go ahead and use a tape diagram to model this problem. I know that they had 614 pieces of candy. Now, again, it says that there were 7 pieces in each bag. So is that saying that they took the 614 and they put them into 7 groups, or does that mean that there were 7 in each group? Well, in this case, there's 7 in each group. So I'm going to draw one section and I'm going to put a 7. And what I'm trying to figure out is the number of groups. So this is how I'm going to show that I don't know how many 7s. I'm going to put a question mark here because I don't know how many 7s there are. That's what I'm trying to figure out. I also want you to notice that it's asking how many bags of candy did they fill and how many pieces of candy were left. So you're answering 2 questions here. I want you to go ahead and pause the video and see if you can't figure out the answer to both of those questions. Okay, so first of all, I thought, well, we're dividing this into equal groups, so I'm going to use division. So I took 614 and I divided it by 7. And when I did, I ended up with 87, remainder 5. So I had to think to myself, so how many bags of candy did they fill? Well, they filled 87 bags of candy. The second question says how many pieces of candy were left. So that would be my remainder, with 5 left over. All right, let's take a look at question number 4. There were 904 children signed up for the relay race. If there were 6 children on each team, how many teams were made? The remaining children served as referees. How many children served as referees? All right, so we read the problem. I'd like for you to pause the video now, and I'd like for you to try to do the rest of this problem by yourself. If at any point you get stuck, you can always press play, and I will talk you through it. Okay, so after I read the problem, my next step is going to be to draw a picture. So I went ahead and I drew my tape diagram. I knew that the total was 904 children, and it said that there were 6 children on each team. So that told me that we were making groups of 6, and we were trying to figure out how many groups there were in all. So to find out how many groups there were in all, I divided 904 by 6. And when I did, I ended up with 150, remainder 4. So I was ready to answer the question, how many teams were made? So this tells me how many groups of 6 there are. So I knew that 150 teams were made. The second question says that the remaining children served as referees, so how many children served as referees? So since my remainder was 4, then 4 children served as referees. All right, let's take a look at problem number 5. Again, we're going to read, we're going to draw, we're going to write a number sentence, and we're going to write a word sentence. So we have 1,188 kilograms of rice are divided into 7 sacks. How many kilograms of rice are in 6 sacks of rice? How many kilograms of rice remain? I want you to do as much of this problem as you can by yourself. If you get stuck, you can always press play. Okay, so let's take a look here. I read the problem, and now I'm ready to draw. So I drew my type diagram. Now I knew that my total was 1,188 bags or kilograms of rice. It said here that it was divided into 7 sacks, and I was trying to figure out how much was in one sack. So I divided my type diagram into 7 parts, and I put an R inside the part because that's what I'm trying to figure out. I put R for rice. You could have also put a question mark. So I knew since I'm putting this into equal groups that I could use division. So I took 1,188 and I divided it by 7. And that gave me 169 kilograms with a remainder of 5. Now you'll notice the question doesn't say how many kilograms of rice are in one sack. It says in 6 sacks. Well, this tells me how much is in one sack. So to figure out how much is in 6 sacks, I decided to use multiplication. I took 169 and I multiplied it by 6 to tell me how many were in 6 bags. So when I went back to answer the question, how many kilograms of rice are in 6 sacks of rice, I had there were 1,114 kilograms of rice in 6 sacks. It also says how many kilograms of rice remain. Since my remainder was 5 kilograms, I said with 5 kilograms left over. So in all of these problems today, we had to figure out if we were talking about the number of groups or if we were trying to figure out how much was in each group. And then we had to really think about what the question was asking. That's why it's so important that whenever you are using or trying to solve an application problem that you use this RDWW process, because whether you realize it or not, if you use it correctly, it'll really help you to understand what the problem is saying and to help you interpret the question.